Hello, everyone. I'm Steve Reynolds, the CEO of Imagine Communications and the chairman of the AIMS Alliance. We're here today to conduct a panel conversation around the dynamic media facility and how this initiative is going to reshape television production and delivery. I'm joined by a panel of experts today, and I'd like to just briefly introduce them. As I introduce each of you guys, if you could just say hello. Naveed Aslam, the Senior Vice President of Production Technology and Engineering for CBS Paramount, and the co-chair of the JTDMF Business Track Working Group.
Hello, everyone.
John Myatt, who is the Senior Vice President of Product Management at Imagine Communications and a board member at AMWA and VSF, the Technical Working Group Chair at AIMS, and also the Drafting Chair for the SMPTE ST 2110 specifications. Andy Rayner, the CTO of Appear, and the Chairman of the JTDMF Timing Working Group, as well as a VSF board member.
Greetings.
And Willem Vermost, the Senior IP Media Technology Architect at the EBU. As you can tell, we have a panel of people here that represent a lot of the preeminent technical organizations in the industry. And this group has been assembled to talk about the DMF initiative, as well as talking about how MXL and SMPTE 2110 play into that. The reason we put this panel together is really to try to demystify some of the understanding that people have about how all of these various technologies fit together. And I really want to thank NABA for sponsoring this panel and for bringing these experts together to have the conversation today. SMPTE 2110 has moved us from SDI to scalable, interoperable IP infrastructures, and ST 2110 works. Much of media processing now runs in software. It runs in a combination of on-premises and in the cloud. And so if everything is now moving to software, we have to ask the question, are we still designing our facilities in the right way? ST 2110, after all, is a standard and a technology that helps connect devices. It has been used as a first step. It's the on-ramp to IP. It gives us a means to get broadcast quality signals around the plant, connecting the infrastructure over packet-based networks, and it's scalable to the workflows that we use today. But we still use codecs to send things up into the cloud. As the infrastructure applications become more and more software-based, ST 2110 will provide a useful layer of interoperability to move material around in the plant in an uncompressed format, but that still leaves room for optimization, for integration, and for better utilization of everything that software can do. DMF becomes that framework for how the next generation of software-defined workflows could work, reimagining the facility as a software-defined environment. Within that framework, MXL provides a specific mode for connecting applications and services, effectively enabling interoperability inside of a computing cluster. This panel today is going to focus on demystifying how DMF and MXL fit together into that next generation facility architecture, as well as clarifying the role that ST 2110 will play moving into that future. With that set up, what I'd like to do first is have John and Willem provide a quick overview of what JTDMF covers, the role that MXL will play within that specification, and then how this interoperates with SMPTE ST 2110 in the media facility of the future. So John and Willem, over to you.
Hey, thanks, Steve. We look forward to describing all of this in great detail, but I'm going to throw to Willem to describe how this all started and where the EBU fits into this.
Well, thank you. And now I'll probably show you a horrible slide with a definition. Don't worry, I'm not going to read this full out, but it's actually very simple what's stated over there. So before rejoining the EBU, I was running the operational plant at a facility somewhere in Brussels, in Belgium, and we thought, well, things that we're doing here could be a little bit more efficient. So we started during COVID, as probably everyone, to experiment with a little bit of software left and right. And suddenly we realized when you start to decouple the interface from the rest of the media functions, that you could do efficiency gains in your production plant. Now, that's not for every production effect. So we started to experiment a little bit more with things like Touch Designer and even an SDI switcher at the back. And we realized there's more to this. Then we started to talk with this idea to many more broadcasters, and suddenly we realized, oh, there might be a next step, looking in more what we call now a dynamic media facility. But this is not something you can buy off the shelf. This is just a vision. This is how we look into the future. But of course, when you talk about a vision like this, well, we come top down. And on the next slide, we figure out how we look at this actually. The reason to build something like this is we always design for peak. When there's elections, when there's Olympics, we made sure we did everything for peak in our facility. But that's not efficient. I think many CFOs are looking at us like, guys, what are you doing? There's even a paper from Skyline that describes that if you look at all your equipment in your facility, 360 days, 24 by 7, only 10% of it's in use of the time. That's a little bit low on average. Now, how can we improve this? And how can we start to share those resources instead of, well, what I needed to do back in the days? I pull out a Betacam machine, needed to roll it to another studio, plug it in, and rewire it. And I must say, that's not a job I love to do. I'm an engineer, therefore a little bit lazy. So if there's a better way of doing stuff, that would be really cool. So how can we share those very expensive resources amongst more productions? That's really what we're trying to aim for. Now, when we looked at it, how does a workflow operate for creating a production? Well, you design your production, you plan it, you need to have the right people, the cameraman, all the cabling, all the stuff, the OB truck, whatever you need to have, you provide them, you make sure you configure it, you operate it, you run your show, and after the fact, you think, well, of all the list, did I have enough equipment or can I do it with less? Now, if we think about a workflow or a life cycle like this, if we would do this in software, it's exactly the same thing. You design your show, you plan your show, you provision it, and maybe provisioning is now more. Do I have the right amount of CPUs? Do I have the bandwidth in the network? Do I have the licenses for all the software I need to have? And the rest is exactly the same. So we thought from an operational point of view in a life cycle, probably not a lot does change. But then when you think about, well, how to create this from a technological point of view, well, you see the typical telecom things. Remember the ISO 7-layer model? It's not a thing you can buy in the shop, but it's a way of slicing the elephant into little pieces and making sure you can get to a solution at some point. So looking at this, if we want to realize our DMF vision, we thought about let's slice our problem in these layers: infrastructure, platform, and a container platform. That's what we think, that's generic IT. There's no reason for the broadcast industry to create special container platforms or servers. There's the IT industry that will deliver it to us. That's nothing new, right? We did the same for 2110. The IT industry will deliver us the switches. Good. Of course, on top of all this IT stuff, we need to have our broadcast specific applications, what we here call media functions. You can imagine a gain controller, an EQ, a color corrector, that sort of things. Really the things that change the media, that add actually value to your production. Of course, on top of this, you see an application and a UI. And it could be anything. It could be your typical board with the knobs and the T-bar that everyone loves to use. Or for smaller productions, it could be a UI, a graphical user interface, because maybe for some productions, you need multiple functions in one space. And even put it to the extreme, I have multiple directors at my previous job that said, if I could do it, I would run the full production on my own. That's, of course, the far end. But this is completely in line what broadcasters are facing, right? We have multiple outlets. Budgets, well, they're not always growing. So how can we produce more? Well, if we can adapt these UIs on the front layer, probably we can. So on many issues or many IDs, it will help us drive the industry forward. As always, there are cross-cutting layers. There's security, that's with 2110, that's there as well. We have monitoring. We can do this now. With SDI, if it fails, you need to work on it. With IT, you can be a little bit proactive with monitoring. We need to control stuff and we need to orchestrate all of this. So that's a little bit our layer diagram, how to create reality from our vision. I did skip a small part, but John, I think you have a lot of slides to explain a little bit what this media exchange thing in the middle should do.
Yes, the media exchange layer is where the media-specific functions interface to the IT generic functions. And that's really where it gets spicy. So the media exchange layer is actually being developed as an open source project within the Linux Foundation. So everybody can participate, and really that means everybody. So there's people participating in that project that are not part of the EBU or AMWA or any other organization. They're just individual contributors with some interest in the work. But the idea of the media exchange layer is that applications can write their output into a ring of frame buffers. Applications can read their input from a ring of these buffers, and there's no copies being made. So it really optimizes how the things interact with each other and how they interact with the underlying platform. It uses memory pointers and some trickery to make sure that everybody can see the things they need to see and gets notifications when it's time to work on them. But the important thing is that this MXL layer is an open source project that everybody is using the same one, and everybody is working on and contributing to the same one. So it's part of the infrastructure that the applications are built on. It's not part of the applications. And that key distinction is important because the MXL is the sort of thing where everybody agrees that we need one, but nobody really wants to write it by themselves. So it's a great way for the industry to work together for the common good to create a unifying layer underneath all of these applications where each vendor adds value. All that said, it's great when you're within one big computer, but often the production is bigger than that. So there is a mechanic as well for how things get copied from one system to another, how they get copied across the domain of all these objects. And that's really where you can scale and run bigger and bigger applications. So the MXL layer will organize this fabric and use RDMA to push buffers back and forth. And RDMA is a well-established technology. It's used in the high-performance computing world today. We do not need to invent it. It is not specific to the television industry. All that said, where are we today? Well, this MXL, like I said, it's an open source project. It's chartered in the Linux Foundation. Anybody, including you, can go participate in it. Just go on GitHub and do a little search. There's the link. If you want to change the code to make it better, you could do that. And in fact, the project is managed by its contributors. There's a user requirements council, which is comes through the EBU, but otherwise it is completely run by its contributors. There is a stable version for the inside the box communication, and the 1.1 version, which adds between the boxes, is, I believe, being demonstrated these days. Now, you might have heard of SMPTE 2110, and that's, in fact, an interesting topic, is how does DMF, or MXL in particular, relate to SMPTE 2110? MXL really targets inside the computer and inside the computing cluster. 2110 is widely used today for going between devices, so cameras, switchers, all the different things you find in a plant. But also, if you think about that computing cluster, signals need to get into it, signals need to get out of it. And 2110 is still a great way to do that. So you can picture one of those applications being a 2110 receiver, 2110 sender, and integrating the connected hosts and the computing cluster into the larger plant. And in fact, inside the DMF, there's working groups above this that are working on all of the different aspects of organizing the whole computation, including how it relates to the things around it. So, Willem, can you explain this eye chart here?
John, could I say that 2110 it's optimized for transport, and that probably MXL is more optimized to be compute efficient? Would that be a good way of looking at it?
That's another great way of thinking of it. That 2110 was optimized for the link bandwidth and cramming as many TV signals as we could into each Ethernet cable, whereas MXL is really organized around optimizing for the computing applications that are at the ends of those links and how much work they have to do to receive and send the video.
So you would really bold it on the side. Now, this eye chart, sorry, there's a lot of details. Don't fall off your chair if you look at it. But it's just saying, like, there are a few things we need to think about when we want to realize our vision, right? The IT industry, they will fix their issues. We will bring this up. But from a broadcast perspective, there are a few things, like we need to be sure that a media function always has the resources that it needs to have to operate. Therefore, there is a resource management group active in the JTDMF to look at this specific question. Now, there's also the question about timing, but I leave it up to Andy to go into details about timing. So those are really a few interesting bits that we chop off and that we start to work on. But what you should get from this graph is like MXL is just a tiny little bit. It's a tiny piece of the puzzle of the whole vision that we need to realize. If we need to get there and if we want to reap all the benefits from a true dynamic facility, we need to make sure that we work on all of these boxes. So some vendors even do say, oh, but what is there for us to sell after MXL? Well, if you look at these charts, you see there's a lot of work for us to do and a lot of opportunities for vendors as well. So don't be bothered about the complexity of the chart, but please do think MXL is just a small piece of the puzzle. DMF is the vision.
Well, thanks for the great overview of DMF and MXL. I do want to just ask a clarifying question here, though, and John, I'll direct this to you, but Willem, feel free to jump in. When you guys are talking about MXL, what really is the data that MXL is operating on? Is it the essences? Is it metadata? Is it control data? Is it timing data? What is really the data that's encapsulated by that MXL layer?
So it is pixels, audio samples, bits of ancillary data like captions, subtitles, what have you. It's the same things that go through the SDI cable, the same things that go through the 2110 flows, organized into buffers so the application receives them ready to use.
With the idea being that by having it in those buffers, multiple applications can actually operate on the same underlying data.
Exactly, that there's shared memory, so they're literally reading the same page at the same time.
Definitely an interesting evolution in the architecture of how we build these dynamic media facilities. But maybe let's go back to the beginning. And Willem, thank you so much for the origin story of kind of where the ideas around the DMF came from. But let's focus first on the question of what problem we're really trying to solve here with DMF and XML. And I'm just going to ask each of you in a sentence or two to kind of define from your point of view and where you sit within the specification development and standards development activity. What do you think is the main problem we're trying to solve here? And Naveed, I'm going to start with you on that.
Thank you, Steve. Yeah, you know what? It's a great question. It's very relevant. I think from our perspective, 2110 and IP-based workflows have largely been understood and embraced as being the next industry evolutionary step. I think we're all there and all understanding that we need to go there. The true value and payoff of going to that IP-based platform has been a little bit elusive for us. We've kind of taken an SDI plant and replaced it with IP, but we haven't necessarily changed our workflows or our methodology and approach. So from our perspective, the DMF initiative is truly the key to start unlocking the practical and technological benefits that we can derive from an IP infrastructure. The opportunities that arise from that, and it just truly starts to give us an opportunity to explore what IP workflows truly can be. And I'm sorry, that was a lot more than one sentence, so I think don't take instruction well.
It's a great setup for the rest of the conversation. But let me throw this to some of the other members of the panel. Andy, from your perspective, what do you think is the key thing that we're trying to solve here?
Yes, so I do think the 2110 IP was quite transformational. I mean, it started off as just an SDI replacement, but the agnosticism of the transport layer that it gave was really important. I think it also signaled a key change where suddenly, as broadcasters, we weren't responsible for the physical layer of interfacing. We're abstracted above that. And that's more and more what we're trying to do. And a lot for me about the whole JTDMF exercise, and specifically the MXL exchange, is it allows compute to behave natively. And I just want to reinforce what Willem said, that it's not a replacement for 2110. This is 2110 still has its place for all of that signal connectivity that needs to happen. This technology is to actually work within the compute infrastructure, and it's going to help in several ways, because we burnt quite a lot of effort with 2110 making computers behave unlike computers, like signals, very smoothly. And what we can do now is we can reduce latency, and we can reduce compute real estate by letting compute behave as compute within that. Again, let's say, benefit with lots of latency reduction and simplicity of operation through this transformation.
That's another set of great goals for the project. John, you've spent the last decade working on 2110, so you're probably into the weeds as much as anyone on that. Where do you really see the DMF project solving some of the problems that you guys encountered along the path of 2110?
2110 came at a time when the industry was ready for what was next. And as Naveed noted, it inherited all of the wishes of all of the things that could become. Now, many of those wishes are a little bit unfulfilled still, because they weren't really wishes that were filled by transport. So 2110 does a great job of utilizing IT infrastructure, utilizing switching fabrics to replace SDI, but it doesn't solve the upper layer problem, which is, if you want to have a dynamic facility, you have to describe what that facility needs to do. If you want to have a show where you can push a button and say, instantiate my afternoon show so I can have the director start directing, you have to have a technical description of what is that show that breaks down to all of the piece parts of that show. I need a 3ME switcher, I need 5 cameras, I need a studio, I need a director, all those pieces. And then have a software infrastructure that can take that requirement list and spin it up and instantiate it in your physical facility. Now, those are just things that got to do. You can do those things probably on top of 2110, as well as doing them in the DMF. It's really the goal of the DMF is to organize those upper layers so that you can actually have a dynamic facility. And I think that 2110 and MXL will work together to achieve that. But there's a lot of work to do to fill in all those blanks in the upper layers and get to where we can walk in on a Tuesday and push the Tuesday button and have all the Tuesday morning things spin up and work.
Willem, from your point of view, what do you really see as being the key goals of the DMF project?
So for me, it's going to be not one sentence either. My apologies. But it feels like, what's being called out as the digital transformation that changed how people connect to broadcasters, that disrupted us tremendously. And actually, what happened on the outside of our cookie fabric did not change enough the inside of the fabric. And I'll give you what 2110 really delivered. We win really scalability. The law of probably every broadcast plant, the matrix is always full. Well, with 2110, you can scale out tremendously. No stress. Liability, yes, it's there. The flexibility, yes, it's there. You can go from HD to UHD without throwing out all your investment. You can keep the network. There's no stress, provided there's bandwidth enough, of course. But then there were a few other dreams that we had already back in the days. And I think on the roadmap that was projected at IBCs, there was this green bit that said dematerialized facility. And that came with a non-functional requirement called shareability. And it would be so cool if all the infrastructure we have, we could use it in a more shareable way, a more agile way between all the productions we need to do in order to get to our audiences, whether it's youngsters, it's elderly people, short form, it might even be lower quality. All those things come into play in today's business. That's what I feel. It's exactly what John says. So this means maybe with 2110, we could do it, but there are a few layers on top that we need to think about. Suddenly, we start to orchestrate our whole facility. We need to make sure that we can plan it better, that we can go from the one to the other production in just a flick on the button. At my previous job, we installed even a LED wall on the studio floor, and we made sure that we could wheel in a set in 30 minutes and wheel it out, so our studio floor becomes more agile. Now with the 2110 setup, you can recall the full show, so that's really great. But if you wanted to produce something small, in that big gallery, I still need to provide all the people to fill the seats in order to run the gallery. So if we get to the UI layer and we can be flexible there as well, that would be a huge business benefit. That's what I see as the main goal for our DMF.
It's interesting listening to each of you kind of characterize your point of view on this, but what I note is that everyone is talking about solving some of the business challenges that the industry has had, especially in this move towards IP. Naveed, in your role at CBS Paramount, my guess is you spend a lot of time thinking about that business transformation. So what do you think will be some of the benefits that DMF brings in terms of things like agility and resource utilization and scalability once this ultimately comes to be?
Yeah, I think Willem and John and Andy summed it up very nicely. We are looking at all of those things because just like everything else, we're a business. Our leadership wants us to deliver on the investments that we're making. The things that we are always assessing is how do we do it faster, better, how do we make the most of the investments that we have, and how do we drive that ROI. In terms of what John just alluded to, into a daily production schedule where we have infrastructure and devices and production tools that are deployed and have always been kind of a bespoke kind of deployment in our facility. The desire for our side and what we see DMF enabling is being able to group and ungroup those resources ad hoc, depending on what the day's requirement is, depending on what even an afternoon versus a morning production session might look like, and allowing us to really try to maximize the availability of the devices that we have, and the infrastructure that we have. I think trying to get past that and trying to understand how we can make that easy, how we can make that simple, and trying to figure out what that magic formula is to unlock the utilization puzzle for us is going to be one of those core objectives for us. That, and we definitely see this as being the step forward to trying to get to that.
In order to get to the place you're trying to go, it seems to me that there has to be a huge emphasis on interoperability and collaboration here. How important do you think that is in the overall DMF process?
I think it's going to be tremendously important. Again, we've done projects where we've tried to choose best of breed solutions and combine things where we felt we were getting the best impact for the investment. It's been a little challenging. We've had solutions that were completely single vendor solutions, and then we've had mixtures, and neither one has been perfect. But I think at our core, I certainly as a user want to be able to pick what, in my estimation, are the best of breeds, that products that really kind of fit my production goals. And they may be different to Willem's today. And we may even have different versions of what a large production versus a medium or a small production scale looks like. And we want to be able to figure those things out. And the only way to really do that is to have effective interoperability across as many of our manufacturer partners as we can.
So Andy, that move towards kind of these open, interoperable, multi-vendor infrastructures, it is very similar to what we see in the IT industry, right? This is not a media only problem. This is something that has happened across numerous industries. So how much do you think the idea of basing these things on those kind of open IT industry principles is going to impact the outcome of how DMF is defined?
Yeah, I mean, I would say my gut reaction is about time, I should say. I mean, I think as an industry, we've been really good at doing bespoke stuff. And as I said earlier, you know, we've removed ourselves from the physical interface by abstracting ourselves, you know, to using Ethernet rather than an SDI connection. The great thing, the reason we're able to do this in 2026 is compute is of a maturity and capability in the IT world that we can just use it as is in terms of the physical infrastructure layers and do our media abstraction on top of that. And we have the bandwidth, we have the processing capability, we have the memory. Everything is there to allow us to sit on top of that infrastructure. And there's a ton of stuff that goes alongside that. It's not just that infrastructure, but the way security has been sorted out by the IT industry and so many other things, deployment, as has been mentioned already. There's lots of things we don't need to do bespoke now. So we can ride on the much, much bigger IT industry as we move forward in this software world and actually leverage all of the benefits there. But still have, the special stuff that we need sitting on top of that, abstracted on top of that to actually give the capabilities. And just witness to what Naveed said in terms of the best of breed requirements. Broadcasters for 90 years in physical infrastructure have enjoyed best of breed, bolt together this box that does this, then this box that does that. And it's insane that we haven't got there yet, but this DMF initiative is the route to us actually achieving that, true multi-vendor software hosting without any penalties of latency or tons of, unnecessary manipulation.
And as that is getting defined, are we adopting some of the best practices of the cloud architectures and cloud industry to bring that into what we're talking about doing with DMF?
Absolutely. I mean, on so many levels. I say everything from the infrastructure to the way we deploy software, to the way we secure software, to the way we do resource monitoring, to the way we do observability. I mean, everything is there, and we can ride on that.
Right. And we've seen this from customers around the world that were using tools like Ansible and Prometheus and Grafana and, the same IT monitoring tools are being used in broadcast plants worldwide today because they work and they monitor the right things.
Yeah, so as we look across all of the different pillars that Willem covered in his introduction, right? Security, monitoring, orchestration. Really, the goal is to try to align those pillars with things that are being more broadly used across the IT industry.
Mm-hmm. For sure.
So Willem, with that in mind, I mean, people ask the question, is what we're trying to do with DMF and MXL evolutionary or is it revolutionary? Which way do you think about it in terms of what we're trying to accomplish here?
That's an excellent question. And probably the slide from John was interesting, right? You had this 2110 network with the cameras. There was a video server on top, and on the right-hand side, there's a little bit of IT equipment. Well, actually, this is how you can start today. You can build your one server and run a little bit of those applications already, and it will be built step by step. You can do it step by step. Nothing works like a radical shift from A to Z. It will be a small evolution that will be there step by step. Even today, there are products on the market that really say, oh, we're using MXL already. Well, maybe you can start with it and see how it works for you. And then hopefully all the rest will be built on top to get to our full vision. So, yep, that's the slide.
Yeah, sorry, what I was going to say, Willem, I get, from that perspective, we can evolve into this. But I think one thing for me that's really important is some of the concepts that are underlying within the compute, within a DMF, is this whole concept of asynchronous handling of data is actually quite revolutionary, because for 95 years in television, we've done a linear stream of stuff, whether it's been analog or digital, and we're moving now to a thing where we're just having buckets of grains, as we call them, and we're throwing them asynchronously, but with important timing information associated with it. And that's actually quite, if people want to get their heads around it, what's actually happening underneath the lid, I would argue is slightly revolutionary as well.
But that's a wonderful view, Andy, and I love what you just said. But it's a keyword that we didn't mention yet. It's asynchronous. But that's really key. When 2110 started, when the first idea was there to move to an IP network versus where we are today, the speed of an IP network is 64 times higher, the bandwidth we have. There are switches today, one ASIC, 102 terabit, meaning 88,000 720p 60 streams in one ASIC, if you wish to do that. But if we look at compute, this means the CPU you get today. If you look at the amount of threads 6 months ago, that was 192. A few months later, we had already CPUs with 384 threads available. This means if we work in an asynchronous way, suddenly more media functions can be run on a compute than ever before. And within the same time frame of a frame, multiple operations can be run. So, yep, if you look at it from that point of view, it seems like a revolution. But if you look at it from your broadcast plant and how you operate it, it's an evolution. We'll get there step by step.
I think what this part of the conversation is underscoring is just the importance of MXL as a part of the overall DMF definition. That media exchange layer, which is the means through which those multiple applications share access to share asynchronous access to the essences, the audio and the video that underlies this kind of a framework, really is one of the keys to making it work. So there's a lot of effort going right now into defining MXL as a standard model for sharing all of that data. I just want to ask each of you, do you agree that MXL is kind of one of the foundational things that we've got to get sorted out here, and that it is something that is absolutely going to have to be standardized? So Andy, you put your finger up. I'm going to let you go first.
Yeah, so I would say the MXL bit is really, really important, but that's the bit we've almost solved now. So we're already on version 1.1, and that data exchange piece, although obviously There's lots of further adoption to be done and lots of refinement. The basic principle is there. For me, it's a lot of the other constructs that we're doing within the JTDMF framework on, he says, personally timing, but also on deployment, on resource management, control, all of those other bits, because it's about making the whole thing work. MXL is a really vital component, but it is only one component of a whole suite of capabilities we need to realize this vision. That's my take.
And I don't think anyone should read too much into the fact that the chair of the working committee on timing thinks that timing is the most important thing. But I think you are correct. It is one of the things we've got to get right. John, I'm going to ask you the same question. I mean, how critical is MXL as a part of this overall definition?
So MXL is important, and as Andy notes, it's largely sorted. The project team has done great work. There's a standing set of code that works. There's augmentation to it, obviously, to go across hosts that's coming together rapidly. So on the whole, I think the MXL layer is well along. But in order to achieve the business objectives, we have to solve the upper layers as well. How do we actually drive demand for a dynamic facility? How do we describe the production? How do we instantiate things? How do we fill in all of those layers above so that you can know today that you're going to have enough equipment to do Thursday night schedule?
Maybe do you see that the same way?
Absolutely, because I think one of the fundamental things from the chair of the business track being so important to this effort is making sure that the economics make sense, that we understand a deployable model, that licensing is addressed and availability is addressed. And as John said, the actual, the bandwidth and the provisioning is addressed in a way that allows us to do what we need to do. One of the comments I was going to add to what Andy was saying earlier is we as an industry have been very used to the bespoke block of iron that's doing a given task, and that's what makes us as broadcasters and media technologists feel really good and sleep well at night. But there's a change in the mindset that has to occur from that proprietary set of hardware into this virtualized software-defined version of everything that truly can do that. And I think the only way that happens is what John and Andy were just saying. There's an element of trust that we all want to and need to gain, that these systems can work and be deployed reliably and, most importantly, consistently in a way that will give me the capability that I need for this afternoon shoot in the studio, and tomorrow morning where I have to do an election, I'll be able to grow this thing out and be able to do what I need to do tomorrow as well. And some of that I think is going to have to come from within us, and it's about engagement and really defining the requirements, as John alluded to earlier, of what it takes to run a production facility and what our use cases are.
Well, let's go a little bit further down that track and let's talk a bit about the operational sides of how DMF is going to impact things. Willem, what are some of the operational changes that you're expecting as we move towards this kind of a DMF approach? And what are the things that you're going to prioritize in terms of what has to be done first as we move towards DMF from an operational point of view?
From an operational point of view, that's a really, really tough question. I would say I had a small team of 6 people who were doing the planning, 6 people knowing the people and know who to plan at what type of job. But if we're in a true DMF, dynamic media facility, it's not going to be the same planning again. Suddenly we need to plan a person, and that person is going to be in a room. And that room could be maybe an edit room, and with a flick on a button, it could be a video gallery. And that video gallery is going to use resources that have licenses. It's going to use CPUs and GPUs. So I think there's something lying ahead of us that we need to be mindful about. And that's probably not so easy because that's a huge change compared to what we're doing today. And you could imagine this like, oh, maybe tomorrow, can I run this production? And it needs to be able to make sure for a person who's responsible for that production that all of those pieces of kit, licenses, CPUs, GPUs, whatever it is available. So that would be a huge chunk of work I see laying ahead of us. But it's necessary if we want to make it work.
Naveed, from your point of view, what are some of the operational challenges that you expect to see as we move in the DMF direction, make things more dynamic?
I think some of the biggest challenges that we have is, we're all running as fast as we can with day-to-day business, and trying to make those innovation steps while we're doing that is a little bit challenging. But at the end of the day, I think we definitely want to be more in control of our destiny. We want to be partnered with our key vendors and partners and manufacturers like yourselves, and know that we can turn to you for the core of the system. But on the day-to-day level and the execution level, operating those systems, we definitely want and need to be self-sufficient. We need to be trained and we need to be comfortable executing that and changing configurations and making sure that what's being deployed in the system today is what we want it to be, without having to use your cycles to come back in and help us with those things. So those are things that I think operationally are going to be important for us to solve, and we're going to have some skin in the game to make sure that we can do that effectively for ourselves. I don't want to always be, knocking on Andy's doors and say, hey, I need you to fix this thing for me. And then Andy's going to be working till later in the night because he already works late to try to solve those things. And there's going to be time there. If we can do this in parallel with our manufacturer partners, I think we can together accelerate the whole time to deployment, which is going to be a big payoff.
So we're coming up to the end of time here, so I do just want to close this out with one final question. I'm going to ask everybody to opine on this. As we move through the standardization and the implementation and ultimately into the deployment of DMF and MXL, what do you see as the biggest risk of moving in that direction, and how would you offset that against what you think is the biggest opportunity? So, Aslam, I'm going to let you go first. What is the risk you're concerned about, and how do you think that's offset by the biggest opportunity?
Look, I think for us, we are embarking on a large-scale refresh of the broadcast center in New York. We see DMF as being absolutely essential in our future state. The concern that we have, or the nagging voice in the back of my head says it doesn't quite exist yet, although understanding that MXL, as Andy said, is a delivered piece. It's actually happening. It's deployable today. Gives me a lot of reassurance. But that's probably the biggest fear, is that we're looking at something and wanting to invest and be part of something that isn't quite fully defined yet. But to counter that, I think the risk of not pursuing that and building a facility that would come online 2 years from now and be essentially on the same platforms as we have today is, I think, a bigger risk for us to take as a business, because the push to deliver faster, better, quicker, and make best use of the facilities and capabilities that we have, I think those pressures are just going to increase for us as a business.
John, you've been through a number of cycles in the industry of technology evolution. You've seen movies like this one before. From your standpoint, what do you think is the biggest risk but what's the biggest opportunity?
I think the biggest risk, and is that we have to make facilities that can be used by their users. And, a lot of this stuff is moderately complicated, right? And as, the sort of early adopters tend to minimize how complex it is to own a Kubernetes cluster and to own an RDMA network underneath it and to own all this infrastructure and to develop it, to own it to the level of understanding that you can trust your career on it working every day is a challenge. Now, the largest broadcasters have engineering teams that can rise to that challenge and do these things, but it's a big world full of many broadcasters of many different budgets. And as much as the earliest adopters can do these very complicated things, these things need to become less complicated and less sciencey in order to move into the broader deployment of the world.
Willem, you work with a lot of the broadcasters that John's talking about there. How do you see risk and opportunity on behalf of the EBU?
So, as with 2110, we had a lot of members that were building new facilities, right? Most of them were built in the 60s. Those buildings have been written off. So they started to renew and they didn't want to, just build with SDI. So they took the jump straight into 2110. And we do see a whole cycle now again. There's our friends from CBC in Toronto. They want to refresh. They're looking heavily into MXL and DMF. There's the Nordics. They're rebuilding right now. That's quite a lot. That's quite an interesting group. And we have a lot of the eastern part that didn't start yet. If I look a little bit in the southern part, not everybody is shrinking. There's a television station that just did build 20 new studios, which is an impressive amount. So if they want all of us to move in this direction, well, we'd better get started. Now, what might be luring ahead of us as a potential threat that we think, MXL went really great, we've done it, finish. No, it's a small piece of the puzzle. And it's like, we have our data plane. Let's now add our control plane to it so that we can manage to connect sources and destinations, or readers and writers. That's the better terminology. Once we have this, they should be common all over the place. We need to dig into all of those other things. And we just need to make sure that we finish the job. Otherwise, we don't reap all the benefits. I would say if we all stick to our guns, we get there, but that could be a potential threat that at some point in time we might think we're done, and we're not yet there.
Andy, I'm going to give you the final word. What are you seeing as the risks and opportunities of moving forward here?
Yeah, I think the risk probably Willem's hit a little bit on already that I was going to say, which I think the risk that we have is the insufficient completion of the toolkit that comprises the complete DTA JTDMF vision, because we need all of those components. Otherwise, each operator that's wanting to use this is going to have to deploy a massive DevOps team to actually create all, tons of tooling to make it work. We don't want that. One of the great things that I think we've learned to do in the last 10 years with IP in the 2110 world is to help abstract the end user above having to understand all the technology, not having to handle IP addresses, that's abstracted up, et cetera, et cetera. And I think what we need to do with this as well is to make sure we have a complete solution available for end users, such that that abstraction layer exists for the control plane, it exists for the deployment, et cetera, et cetera, et cetera. So we've actually got an easier, and I'm not going to say easy, but an easier to use total capability. In terms of the transformational stuff, I do, as I said earlier, I do think this is quite revolutionary. I think it's really exciting. And I also think we're talking about kind of this like a DMF instance or the concept, but actually it is pervasive end to end. And my challenge of thinking is saying, we're thinking about this kind of asynchronous lump of compute in the middle, but if we think end to end from glass to glass, from camera to display, my question is in a few years' time, I don't know how many that is, how much of that complete end to end will be really completely asynchronous? It could be much bigger than just the compute in the middle. As long as we have a real time acquisition of the shutter and the sampling of the audio and the same display at the other end, the rest, it's all up for grabs. Let's do it.
Well, that's a great place to wrap up, keeping things focused on the business benefits that we're all going to see out of this and making things easier for the users. If we can keep that in mind, I think it's a good way to move this forward. So thanks to all you gentlemen for participating on the panel today. I know we covered a lot of ground. Thank you for everyone out there who's watching for sticking with us through the entirety of that. And looking forward to following up on this conversation as DMF and MXL continue to mature. Thank you.
Thank you.
Thank you.
Thank you.